I have a habit of using tools in my way rather than the intended way. Why use a crowbar when you have a screwdriver? Why use a screwdriver when you have a wrench? But more on point, how about electronics tools like a bench power supply and a multimeter? There are ways you are intended to use these. There are ways you are intended to hook them up, as witnessed by the connections that come with them and the additional accessories you can buy for them. I still did it my way. The problem is my way is awkward, and it involves daisy chaining and clamping things onto other things and just hoping you don't accidentally short them when you're not looking. So now that I have a soldering iron and a few other accoutrements, I'm just going to make my own cables. I already looked. Nobody sells them. Oh well. Let's go. First up, the cables for my bench power supply. Now the first thing I'd like to mention is it has 3 connections. Black is supposed to be your common, your negative, your ground, your whatever, your circuit ground. Green is your earth ground, your actual ground, the only thing that should be called ground. And your red is your positive, your high potential, your hot line, whatever you want to call it. And these cables are a banana plug on one end, which is just a pole that's a little bit bowed out so it applies pressure when you stick it in, and an alligator clip on the other. And of course I got a cheap Chinese power supply which works just fine, but they didn't see fit to actually include 3 wires despite the fact that they have 3 places to put wires. So we'll just let that slide. But why alligator clips? So on more proper breadboards, not just loose ones, but the professional ones, you'll notice these 3 holes. Something's supposed to be there. They're actually screw terminals that are unsurprisingly colored red and black. And what you're supposed to do is use those alligator clips onto these poles and then connect wires to those poles and connect them to other things. You'll notice, like I said, there's nothing in there. That's because that annoyed me. It was getting in my way. This was a nice flat space if I took them out. But the additional step of having to hook on an alligator clip and then wrap something else around and stick it in the breadboard, and it was just too restrictive. So despite the fact that that's how you're supposed to do it, I just said, I won't. So instead, what I would do is I would have the banana plug in the bench power supply connected to an alligator clip. Then I would use this other kind, which is a special one I got from SparkFun. These you can actually buy. It's an alligator clip on one end and a jumper wire, header pin, whatever you want on the other for putting in a breadboard. Because I do everything on a breadboard. So why do I want alligator clips and probes and all this other crap when I want to put it in a breadboard? But nobody sells bench power supply or multimeter cables for a breadboard. So what I would do is I would just have 2 alligator clips hooked together and then this going into my breadboard. This is a terrible idea. Don't do that. Because frequently I would find that the negative and positive ones were coming very close together and almost shorting across my power supply, which is not terrible because it has current limitation. But it's quite awkward, and also, these alligator clips are nice, but they're awkward because the insulated grips are slippery. So what happened is, the banana plugs, they have something that's basically a screw terminal on them. It's just a screw inside that bolts down on a wire. So I unscrewed them, and I screwed in an actual male-to-male header wire, which works great, but it's too short. So what I'm going to do instead is extend it. Now, I only have this wire. This is 14 gauge copper. It's going to work fine, but it's really stiff. So I'm going to have a stiff part and an unstiff part. And that makes me sad, but like I said, it'll work just fine. So the first wire I'm going to do is the bench power supply ones. So let's start with the negative terminal, which I happened to rip out, which is another reason why I'm going to redo this. So I'm going to loosen the screw on this terminal so I can get stuff into it. That's all it is. It's just a screw in there that presses down on a bare part of a wire. So I'm going to cut a length of wire. This is going to be quite approximate. And I really do wish it were not this stiff, but I like it being this thick because it'll make it easier to screw down. So this is 14 gauge wire, so just stick it into your strippers, the proper setting, and as usual, I'm sure the insulation is going to fly across the room. That's one trick I haven't figured out. How do you strip wire without it landing wherever it wants to land? So I'll just strip both ends of this wire. So that's one part, that's the extender basically. Nice and thick so it's easier to get a grip on. And the other one is going to be a male-to-male header wire. And I may as well use the one I ripped out because I had already removed the end. Now this is stranded, which is fine if it's pre-made, but it's hard to work with stranded. But we're going to do what's called tinning. So this end is perfectly fine, and this end I'm actually going to cut and strip again to get a nice fresh piece. Now, I have no idea what gauge this is. So when you don't know what gauge your wire is, start with one that's too big, keep going down until it seems to fit snugly, and as soon as it seems to fit, there you go. Assuming it's a standard gauge, you'll be fine. So now we have that. So what I'm going to do is forget to turn my soldering iron on, so now I have to wait. But what I'm going to do is basically put some solder on the end of here so it's not stranded anymore. It's a soldered thing. And then I'm going to use something called a crimp tube. So let me get my solder ready because my soldering iron is already almost done. This is leaded solder, so remember, you're going to want to wash your hands and not lick your fingers. So just go ahead and clean the tip a little bit using the flux in the solder. There we are. Good enough? So now, since I don't actually have a good surface to do this on, see, I have a helping hand thing coming in the mail, but I don't have it yet. So I'm just going to turn over my breadboard and use the middle side, because if something goes wrong, I can just clean it up. Nice and easy. Actually, that makes sense. I'll just go ahead and have the soldering iron sitting there in a really stupid move, but I'm right here. If it falls, I'll just turn it off. Don't worry. So I'm going to touch the wire to the soldering iron and the solder. I'll turn it over and do it again. And now I have a nice tinned wire. And it just occurs to me that I could have put the solder on the soldering iron and then applied it, but solder seems to apply easier if you heat the wire and apply it to that, rather than just dripping it on. So there we go. It's already almost dry, but we'll wiggle it around a little bit. And of course, that was really quick. You're like, 750 degrees, how did it not melt the insulation? Because it was quick. It's not just the rate of heat transfer, it's the amount of heat transfer. A lot of people say don't have it too hot just in case you fry something, and I'm sure I'm going to fry something. But the advice I read on the internet is actually hotter is better if you can do it right, because you're in and out quicker. So I'm trying to do it that way, and we'll see if I do. So now I get a crimp tube. A crimp tube, or in this case, according to the box, it has the much more amusing name, the butt splice. What you have is a plastic tube, and inside the plastic tube is a metal tube. And you basically stick your wires in either end, and you smash it down, and the metal grabs onto the wires so they don't get out. Now, there are actual crimping tools, but I think we found ourselves in this situation because I don't use tools right. And I really don't want to buy a crimping tool to crimp like 6 wires ever. So instead, you use locking pliers. The way these work, so normal pliers, it's just you grab. But these have a little adjustable thing. So you can tighten them, and then if you tighten them just enough, they will not completely close, but then you give it more force, and they lock. And then there's a little lever here because it won't come out. You press a lever, it comes loose. So these are super handy for, like, if you want to put a shower head on or something. You lock it on and just turn it around. But the idea here is it will apply a lot of force. So I'm going to put this wire in this end of the crimping tube, and I'm going to put this wire in the other end. And if I could partially crimp, I think I'm actually going to use my needle nose pliers to crimp just a tiny bit of one end because I'm running out of hands. So I'm going to put this wire in one side of the crimp tube. I'm going to squeeze out just that end. It's supposed to squeeze down. And oh boy, that is really strong, which is good. It's high quality. So if you can't apply enough force with your pliers, remember your simple machines. Put the force closer to the fulcrum and it's going to slide out. But now you can apply more force. My goodness. This might be why there are crimp tools. So I'm going to have to use the pliers, which can apply a ton of force, to go ahead and try and crimp this end. My goodness, I should have bought a crimp tool. Yeah. Well, we're stuck now. Certainly can't go buy one in the middle of the video. So we use our brain and also our muscles. All right, there we are. That secured that end. I almost needed pliers to get my pliers loose. So now I will take this wire in the other end. I'll go ahead and crimp that down. So I'll stick that in there. Gonna do my pliers just like before on that end. With great energy. Holy crap. Oh. And I've done it crooked, of course. So let me do the middle and try and do it less crooked. This is why I bought a pack of 10 crimp tubes, because I'm going to make mistakes. Oh yes. All right. I can admit when I was wrong. I should have bought a crimp tool, but I'm still going to make this work. There we are. Good thing I only have to do that 3 more times. So now, with this expertly and professionally crimped pair of wires, we have a nice secure connection that's also insulated, so it can wiggle around and be perfectly fine. And while it's annoying that this end is stiff, that also means I can form it into a shape so it'll stay out of the way. So now, this end's already done, of course, so I will take the banana plug, and you just put the cable into the banana plug, and you screw it down. And it would be better if I could use the other screwdriver for a better grip. Of course, I don't want to strip the wires, but you just secure it down, and then you use your flashlight to make sure it's in there, or actually I have enough light. So it is grabbing it. So let me squeeze a little bit more, just enough to not strip. Now, very quickly, we simply test to see that this is a valid wire using our continuity mode. So we put the meter in continuity mode, confirm that the meter is working right, then we test it this way, very awkwardly. And we're good. The crimp connection is continuous. The banana clip screw terminal is continuous. So now I have a new power supply negative wire. And there it is. I may eventually get a real crimp tool and modify that again with wire that's not as stiff, but for now, that will be fine. So now I will go ahead and take the red one that did not come loose, or rather that I did not rip out, and we will repeat this process. I will cut off the end I had stripped before, and this turned out to be, looks like 18 stranded, or was it 16? No, it was 18 stranded. There we are. So now the back of the breadboard to put my soldering iron on, and we'll get this puppy squared away. So apply the wire to the heat and apply solder to the wire. And yes, when I lean over that way without a fan, the smoke does go directly into my face, but I'm not breathing. I'm holding my breath. And then you just breathe out while you lean away. Better answer, have a fan on. But I'm sacrificing airflow for less noise for you people. You're welcome. There we are. Not great, but not terrible. Story of my life. I don't actually aim for greatness because greatness is way too much work. I aim for mediocrity because I can be mediocre in almost everything and a failure at very few instead of being great at a couple things and a massive failure in the rest. I believe they call it jack of all trades, master of none. Won't make you famous, but it'll keep you from getting ulcers. So now I'll get this back out of my way. I'm going to get out a new crimp tube. So I'll go ahead and crimp down this end with all of the strength I can muster. How much strength can you muster, mister? So I'll try to crimp just that side. Don't get your finger in there. Oh. Pure cussed stubbornness. But it works just fine. So now I will cut another length of this wire. I suppose I should try to make it roughly equal. I'll take the other one out, put it about there. All right, put you over there. It's not going to matter too much. And we know this is 14. Remember, on your strippers, solid and stranded are different settings. This is a solid wire, which is easier to work with, but stranded has its uses. So now I have my nice stripped wire. Put that in there, and the fun part. Muscles. Try and keep it flat with the other part. Oh my god. I have to actually use my immense bulk as leverage here. Oh, almost. Oh, criminy. Ow. I'm pushing all of the blood out of my hand. Ladies and gentlemen, buy a crimp tool. Ow. And gravity. So now let me just crimp the middle, because that was the two ends. So now we have the middle. Make sure it's nice and tight. And there we are. Nice and secure. Test for continuity. Positive here, negative here, and we're good. But I should have put the banana plug on first, so let's do that. We'll just screw that right on. I can feel it twisting the wire, so it should be good connection. But we test anyway, because that's how we are. We test around here. And good news. Project complete. I now have two custom bench power supply plugs. Banana plugs here, breadboard plugs here, nice insulated connections with no danger. And now for the multimeter probes. So if you weren't aware, the reason they're called probes is because they are literally probes. You are meant to put these on the case or a leg of something, or just touching bare metal in places to measure it. Much more in the field industry tools, not breadboard. There are other attachments. For example, I don't know where I threw them, so you'll have to take my word for it, but there are alligator clip types, and there are even ones that are designed to go on the legs of integrated circuits. It's a little grabby thing. It's a little pin, and you hook it around the leg, and it sucks it in and grabs it with a little bit of plastic. So you can use a multimeter on the individual pins of a very small integrated circuit. But I want breadboard cables, and they don't freaking make them. So I'm going to make them. So multimeters use their own kind of plug, of course, but the simplest thing in this case, because multimeter probes are standard and I got a standard multimeter, I just bought a set of replacement probes. It's just new probes in case you break your old ones. So now I won't need my 14 gauge wire for this. It'll be nice and supple. So let me put that aside. We'll start with the positive. So this is the end that connects to the multimeter, which is basically an encased banana plug for extra safety. But here's the probe end, and here's the one I want to replace. So to maintain length, I'm just going to go ahead and cut it off right there. And I'm probably not going to be lucky enough for this to strip properly, because I doubt this is a standard size. Oh, that didn't work. Yep, that actually halfway cut through in a weird way. So now we have to get creative. Well, let me try one size smaller. That might work, as long as I have most of the wire. Aha! There we go. See, don't give up. So what you want to do, if you do something like that, you look at the base of the wire right where you stripped it and see if there's any nicks, and there are not. So that just barely worked. So now, this is unfortunately but unsurprisingly stranded. So I'm going to have to tin it as well. There we are. So let me just tin this wire. There's actually a bit more of it because it's meant to carry more current. At least if you accidentally get a whiff of the solder, it doesn't smell bad. But on the other hand, you're breathing lead, so don't do that. You're mostly breathing flux, but you're breathing a little lead. And this wire is getting a little warm, so let me cool it off a bit. I had it on there longer because there's more wire. So I'm almost done, so let me get in and out quickly. And there we go. Nice and tinned. So while I let that cool, hanging off that shelf there, let me separate that so it doesn't heat the base as much. I'm now going to need some header wire. So let me go ahead and just take a male-to-male wire here. Cut off that. I believe we decided this was 16 stranded. No, this is thinner. Or did we say 18 stranded? No, it's even thinner. This is well, I've already cut it now. Is the alligator clip thicker? Oh, it is. Yeah, I'll tell you what. It's better to use the thicker wire a little bit. So I will go ahead and sacrifice an alligator clip. You can actually clip the clip onto something else. I'm not ruining the alligator part. So this must be the 18. And yes. So let's get that tinned. I have spares. I'll just have to get some more or make some more. There we are. Get the residue off. And now I will leave this one to cool while I go ahead and crimp the one over here that should be cool by now. And it is. Perfectly cool. So we'll do just like before and hope my hand can handle it. My tools always get buried while I'm using them. So I'll go ahead and shove that in and squeeze. Ah, there we are. That's secure. This one's cool, so stick it in the other end. Let me actually put the crimp tube in the pliers first. The butt splice, whatever you prefer. I prefer calling it a crimp tube because it's a tube and you crimp it. But, you know, I'm just talking crazy talk here. Alright, so that should secure that wire in that end, and now the middle. I'm getting better at a skill I will never need again. So there's one. See? Don't let the fact that something doesn't exist limit you. Make it exist. So now I will take the spare negative probe, take the cap off, trim off that end, and I think we decided this was 14 stranded. Let's see. Yes. Check for nicks, and get her nice and tinned. Squeeze that together a little bit. All right. A tinning we go. It's actually fun seeing the solder wick along the little stranded wires. It's kind of like working with mercury, which I've never done, but I watched Cody do it. The fact that you have a metal that acts as a liquid is just really neat to me. So we'll let that cool. And while I do that, I find, aha, that was quick, an alligator clip to sacrifice for the cause. So this one was 18 stranded. There we are. And this will be our final tinning for the evening. And a good thing solder is cheap, because I'm using a bit of it. It's more expensive, I think, if you get the stuff without lead, but if you take simple precautions, it's fine. If you're pregnant, don't do it. If you're a child, if you're old, if you're pregnant, don't work with leaded solder. But everyone else, it's just like, wash your hands and don't lick your fingers until you've washed your hands. Because the lead is not dangerous until it's inside of you. Don't eat it, don't breathe it, and you'll be fine. There we are. So that's all nice and clean. Turn off the soldering iron because it does take time to cool. It's quite a bit of time. But now we're only crimping. So I'll take the cool one. I mean, the solder does cool almost instantly enough to not be molten anymore. But I want the residual heat out as well. But pretty much by the time you have removed the soldering iron, it's already solidified enough that it's not going to just drip off. That is kind of the point. So insert crimp tube into wrench. Insert wire into crimp tube. And squeeze like you've never squeezed before. Oh, Jesus. Who needs a crimp tool? Are you kidding? All right. That side's in. See, now I figured it out. There's the black one. Put it in the wrench first. I asked my mother about it, and she said the reason to actually use a crimp tool is because it doesn't just squeeze flat, it squeezes in multiple points and helps it lock on better. And I have no doubt she's right. So if I were making something to sell or to give to someone else, I absolutely would have just stopped this video and gone and gotten a crimp tool. But this is for me. I'm the only person who has to be happy here, and I will be happy when this middle part is crimped. Blah! And there, ladies and gentlemen, are homemade multimeter probes with breadboard connections. Still somewhat delicate. This is not going to be good enough for field work. And also, this end is much thinner wires, so it's not going to handle a lot of amperage. But I don't need a lot of amperage. But there you are. Let's test them in my multimeter. So I'll plug the red into the main, the black into the common, and we'll use the continuity test to test its own probes. And a beautiful sound. Despite my cavalier attitude, I do prefer professional tools. They're more sturdily made. If you break them, sometimes they're under warranty. Or if it's your fault, at least you can just go buy another pack or buy several in the first place. Certainly quicker to order something and then wait for it to arrive than everything I've done here. Not pictured here was the time spent shopping and researching. But, like I said, I tried. They weren't there. I'm not trying to save money. It's not like the oscilloscope where I can't afford, $500+ for a quality oscilloscope, and crappy oscilloscopes are a literal burning of money. Just stick it in a fire, and at least then you'll get some pretty smoke. Whereas I simply made my own. That's still not great, but is mine. I learned from the experience and was only $20, or technically $0 because I can just reuse the Arduino. But multimeter probes are not going to be that expensive. But in order for me to buy them, they first have to sell them. I have no doubt that there are people all over the world that have the same problem as me that want to use them the same way as me. And sometimes they just get frustrated and don't. And sometimes they'll try to shove those probes into the breadboard. And sometimes they'll do what I was initially doing and just chain alligator clips together. But hopefully, some people also do what I just did. Run to the hardware store, get a $1.50 box of crimp tubes. I do recommend a crimp tool now, but the wrench definitely worked. And for the price of another set of probes and wire cutters, there you go. Don't be afraid to improvise. Don't be afraid to do something, to get something, to make something that you decide you need. Just because it doesn't exist doesn't mean you don't need it. Don't look at the fact that you can't buy it as an indication that you shouldn't buy it. That's not how the market works. Sometimes something just doesn't exist because people improvise or do something else. There's not enough of a market. They're too busy making something else. There are way more hobbyist electricians than there are actual electricians. And I don't mean training electricians. I mean people like me that have no desire to be an electrician. I'm just messing about for fun. There's way more people like that than professionals. So you'd think the demand for this product would be much higher because we're all using breadboards. But it just didn't turn out that way. Listen to Frankie and do it your own way. And while you're doing that, I'll be seeing you.